Hello, good morning. I'm discussing structure and properties, a general opinion of chemists adopted by textbooks in that in chemistry. Structure is a central concept, the key, everything, properties of given substance depend on the number and nature of its constituting atoms and their mode of connection, connectedness. After having defined the concept of structure, we will proceed to discuss correlation of structure and properties with special emphasis on the special features of structure and properties. Orbital shell, fixed part along which electrons revolve around the atom's nucleus. Orbital, volume of shape about the nucleus of an atom where there is a high probability of finding an electron is known as orbital. Atomic orbitals. Atomic orbitals are mathematical functions that provide information about the nature of electrons, pair of electrons that exist around atomic nuclei. Atomic orbitals have characteristics of quantum numbers n, l, m, s half, and s minus half, principal quantum number, azimuthal quantum number, magnetic quantum number, and spin quantum number. An orbital can accommodate a maximum of 2 electrons, which poses the same energy but opposite spins. There are different types of orbitals called SPD and F. Subshell SPDF orbitals is PXPY. Total numbers of orbitals 1 in S subshell, in P subshell 3, D subshell 5, F subshell 7. Hybrid orbitals, an orbital formed by the combination of two or more atomic orbitals. Hybrid orbitals are formed by the hybridization. Hybridization, it is the concept of intermixing of orbitals of atoms having the same energy to give exactly equivalent orbitals with the same energy, identical shape, and the symmetrical orientation in shape. For example, sp hybridization, sp2 hybridization, sp3, sp3d, and so on. Molecular orbital. In chemistry, a molecular orbital is a mathematical function describing the wave-like behavior of an electron in a molecule. Melting point. It is temperature at which a solid is equilibrium with its liquid. Liquefies at standard pressure and above which the solid melts, or it is the temperature at which change state from solid to liquid, water to ice. Definition of acid and base. Ernest concept. An acid is a chemical species whose release H plus on dissolving water, for example, hydrochloric acid, sulfuric acid, nitric acid. A base is the chemical species which release hydroxide OH minus ion on dissolving water, for example, sodium hydroxide, magnesium hydroxide, calcium hydroxide, etc. Bronsted-Lowry concept. An acid is a chemical species which is a proton donor, for example, S plus. Base is a chemical species which is a proton acceptor, S plus, for example, ammonia. Lewis concept. An acid is a substance which is electron pair acceptor, for example, aluminum trichloride. A base is a chemical substance which is electron pair donor, for example, ammonia. Covalent bond, the bond formed by mutual sharing of electrons, polarity of bonds. The bonds polarity of bonds is due to dipole moment. Dipole moment is a product of charge and distance. The electron pairs shared between two atoms are not necessarily shared equally. Non-polar covalent bond, the covalent bond in which the electrons are shared equally between two atoms, for example, chlorine molecule. Polar covalent bond, the covalent bond in which one atom has greater attraction for the electrons than the other atoms. If the relative attraction is great enough, the bond is ionic. Electronegativity, it is defined as the ability of an atom in a particular molecule to attract electrons itself. For example, halogen groups have the higher electronegative and alkali metals have the least electronegative. The molecules having the dipole moment are called polar molecules, whereas zero dipole moments called non-polar molecules. Electronegativity difference, types of bonds. For example, in case of fluorine, the electronegativity of fluorine is 4, so 4 minus 4 0, and non-polar covalent bonds. In case of hydrogen fluoride, the electronegativity of the hydrogen 2.1, so 4 minus 2.1, 1.9, polar covalent bond. Polar covalent bond is the electronegative difference greater than 0 and below 2. In case of lithium fluoride, the electronegativity of lithium is 1, 4 minus 1, 3, so ionic bond. Inductive effect. Inductive effect occurs when a molecule experiences an uneven distribution of bonding electrons, leading to the formation of a permanent dipole in the molecule. The redistribution of electrons is caused due to electron donating or electron withdrawing groups in the molecule. Positive inductive effect plus I effect. Positive inductive effect is seen in atoms or groups that have a tendency to give electrons. It describes the ability of a substituent or functional group to donate electrons density to a neighboring atoms through the sigma bonds. Alkyl groups are well-known instance for groups that donate electrons such as methyl, ethyl, propyl, and so on. The observation of the positive inductive effect occurs upon the attachment of these groups to a carbon atom. Negative inductive effect or minus I effect. Negative inductive effect can be observed in electron withdrawing groups or groups that tends to withdraw electrons density from a neighboring atom through sigma bonds. Common examples of negative inductive effects are oxygen, fluorine, chlorine, and bromine. The observation of the negative inductive effect occurs upon the attachment of these groups to a carbon atom. It can influence various chemical properties and reactions of the atom. Order of inductive effect. The order of inductive effect is determined by a group's ability to donate or withdraw electrons density from a molecule. Higher electronegativity electron withdrawing groups have a stronger inductive impact. Lower electronegativity electron donating groups have a lesser inductive effect. The order of inductive effect is given below: halogens, electronegative elements, alkyl substituents, aryl substituents, alkylidene and arylidene groups. Inductive effect on acidity and basicity. Inductive effect can be used to determine the acidity and basicity of various compounds. Electron withdrawing compounds become more acidic when substitutes are sigma bonds to remove a molecule's electron density away from it. The reason for this is that the reduction in electron density facilitates the donation of a proton. Halogens such as fluorine and chlorine, carbonyl groups, nitro groups, etc. are few examples of electron withdrawing groups. Electron donating groups becomes more basic when substituents by sigma bonds contributes electron density. This is due to the fact that the molecule may more easily take up a proton as plus or proton acceptor when electrons are available. Alkyl groups, hydroxyl groups, amino groups are few examples of electron donating groups. A positive inductive effect will decrease the acidity of a compound, and negative inductive effect enhance the acidity of the compound. In this example, inductive effects acidity and basicity, electron withdrawing groups stabilize the compound, increasing acidity. Electron donating group destabilize the compound, increasing basicity. Inductive influence on stability of molecules. According to the inductive effect, The stability of the resultant molecule is strongly dependent on the charge on a particular atom as well as the charge on a group that is bonded to the atom. A group that exhibits shows the negative inductive effect can be linked to the positively charged atom to reduce the stability of the resultant molecule by amplifying its positive charge. However, when an atom with a negative charge is added to a group that exhibits the negative inductive effect, the charge difference is substantially reduced and the new molecule would be stable due to inductive effect. Difference between inductive effect and mesomeric effect: electron density transferred by sigma bonds in case of inductive effect, but in case of mesomeric effect, electron density delocalization by lone pairs or pi bonds. It is effective up to 3 carbon atoms in case of inductive effect. It is applicable along the length of the conjugated system in case of mesomeric effect. It operates in a saturated and unsaturated compounds. It operates in unsaturated and conjugated system in the case of mesomeric effect. Difference between inductive effect and resonance effect: inductive effect is caused due to transmission of electrical charge between atoms in a molecule. Resonance effect is caused due to transmission of electron pairs between atoms in a molecule. It occurs due to polarization of bonds. It occurs due to presence of single and double bond. It is affected electronegativity of the atoms. It is affected by arrangement of double bonds. Difference between inductive effect and electromagnetic effect: it involves displacement of electrons along the sigma bond. It involves displacement of electrons along the pi bonds. It is permanent. The inductive effect in case of electromagnetic effect, it is temporary. Partial charge separation takes place in case of inductive effect. Complete charge separation takes place. It changes the molecule's total electron density. It only modifies the electron density at a multiple bond site. Attacking reagent is not required. Attacking reagent is required. Hydrogen bonding: a chemical bond in which a hydrogen atom or one molecule is attracted to an electronegative atom, nitrogen, fluorine, oxygen, at the same or another molecules. Hydrogen bonding are two types. Intermolecular hydrogen bonding: if hydrogen bonding occurs between the atoms of two different molecules, then such type of hydrogen bonding is called intermolecular hydrogen bonding. Hydrogen bonding in alcohols and carried out by methanol as shown is this is the intermolecular hydrogen bonding of the methanol. This is the dimer of the carboxylic acid. This is also intermolecular hydrogen bonding. Intermolecular hydrogen bonding: if hydrogen bonding occurs between the atoms of the same molecule, then such type of hydrogen bonding is called intramolecular hydrogen bonding. This is the intramolecular hydrogen bonding between orthonitrophenol and salicyldides. Physical significance of hydrogen bonding: solubility. When the van der Waals force of attraction can overcome by solvation energy, the compound is considered dissolved in a given solvent. Polar solvent only dissolves polar compounds like sodium chloride, potassium chloride, etc. However, some of the organic compounds, non-polar, are also dissolved in water due to hydrogen bonding. Example: alcohol, carboxylic acid, phenol, amines. Melting and boiling points: higher molecular weight, higher is its melting and boiling points. So a molecule in the form of the dimer through hydrogen bonding, melting point and boiling point of dimer is practically then expected. Example: alcohol has melting point and boiling point, then carboxylic acid of compounds comparable molecular weight. Okay, alcohol has higher melting and boiling point than carboxylic acids of compounds of comparable molecular weight. Okay, it's all about structure and properties. Thanks for watching and request you all like, comment, share, and subscribe. Thank you for patience. That's now bye bye. See you again.